Okay, so either for calculation program or the DLab on textual program, the process will be the same. Okay, only the difference will be the test. The test in the calculation program is different from the DLab. Okay, so now first thing, when you start it, double click on the visual stereo icon. I don't know where you put your, but on mine, I put on the desktop. Okay, then next step, select new project. Okay, and make sure you will be in Win32 console application. Now you will be typing the name. I can say e-calculation. Okay, if you on textual, and you can type in DLab 1, 2, 3 or whatever. Just the name of your project. Okay. Then you have to know where you want to save the project. You can go to browse. Okay. Then you can select where you want to save it. So I can put it in ATT, that'd be fine. Okay. And click on select folder. Okay. And then you can click to OK. Okay. Next will be click Next. Okay. On this window, click on empty. Let's see. Unclick that. Unclick that one. Click on empty. Okay. Then finish. Okay. Now right click on your project on my e-calculation. Right click, add new item. Okay. Make sure you get the file. And now you can type in the name. You can say e-calculation. Okay. And you click add. Okay, now also you have to do right click on your e-calculation project here, property. Okay, let's see. Common, click on common language support. Okay, click on the arrow here. Click on common language. Okay, class CLK. Then you say apply and you say okay. So that is a completely the program. Either on the left or in calculation, you have to do exactly the same thing. Okay, up until this point, anyone get a question, anything?
Yes, I got lost in the last thing you did after you did the new item.
Add new item. Then they go into the C++ window. You type in the name, right?
Yeah, so I did that e-calculation. I got the new item. The only thing I don't have is the last one that you did. When you open it, you open something to be able to do something with the file or something like that.
Okay, right click on your project. Go to property. Okay. And click on common language.
Sorry, I'm trying to find properties.
Okay. Then click on the arrow. Okay, select C/CLR. You see that?
No, I can't find properties.
It's best if you can share your screen and so we can help you quickly.
Okay.
So you may stop sharing.
Yes, so he can share his screen so we know what he's talking about, Yes.
Oh, there's properties. I found it.
Okay.
So I go to properties, it's all the way at the bottom, and then where?
You want to do just click on it and then and we do have the instruction on the website. You can go into the instruction. It's way on the bottom on that. If you go to the website, go to handouts.
Yes.
And if you scroll to the bottom, and it said how to edit 2015 C++. You click on that show you how to, that give you a pretty good instruction how to set up your template to write your coding.
Oh, okay.
Okay. All right, so yeah, anybody else have any other question?
So that's the basic. For either take one or take two. That have to be no problem when you try to get into the C++. Okay, if it's not, I share my again. Okay, so that one already done. Now, the next thing. In the website, I already given you a sample. So now you can go into the website, okay, and try to get handout. Okay, we have the sample right here. a calculate sample. Click on that. You see that? Okay. Next step will be move the cursor to the top. Okay. Then press the Control A. That means you try to copy everything. Then Control C. Copy. Okay. So you can leave it out. Now go into your video. Control V. See that? You get everything. Now I try to explain to you. First thing, you understand / with the commands, right? They will be green. You type in your project name, whatever name, and you type in your CPP file. Programmer, you change to your name. Don't leave my name, okay? Version date, that means the day you do it, whatever day. Okay? Then you just see on that one here, including here. Okay, you don't care. Now, next thing. When you do your calculation program, you need to declare the variable and the value if they have it. Okay, I show you. This is sample here. You can see in here, you get a variable RB, RC, VBB, VCC. Okay, so that's why you can say double RB equal okay 1,000, 10,000 ohm. Basically RB equal 10K, but you cannot using 10K. Computer cannot understand. Okay, so they will be by O. RC double equal 100. This is the command here. We try to explain to you, okay, what the value in the schematic. Okay, and VBB, you get 5, but not 5 volt. Okay, they don't understand 5 volt. They understand 5, and that's why I put command VBB equal 5 volt, VCC equal 10. Okay, and the beta they given to you is 150. And you understand the voltage from the base to the meter, that the diode 0.7. So no matter how many variables, you must be get a decoration. Okay. So we go to this thing here, H1. If you question, stop me.
Mr. Friend,
Yeah.
when you say it doesn't know voltage, what you mean is the digits only represent a mathematical sequence versus the program actually measuring 5 volts.
Yeah. However, when you're working on the software, okay, variable, you cannot say VBB equal 5 volt. They don't understand 5 volt. They understand equal the value 5. But you have to understand that will be a 5 volt. You can see on of the decoration. They just using the number, no unit.
One last question regarding the volts. If you wanted there to be an understanding for volt, you would have programmed that into the IO or the firmware, correct?
You mean from the IO.
Yeah, you would have programmed yourself when you wrote the language. You would have wrote VOLT, and then that would be recognized by the program that you're writing on the screen. So if volt isn't in the IO or the firmware, and it's not defined to measure the voltage, then like you say, it won't recognize it. So it literally has to be written in the IO or the firmware, correct?
Now, basically you understand variable. They contain only the value. They don't contain anything else. And the value have to be just a number. Okay? If you want they enter by millivolt, then you have to tell them in millivolt. Okay? 5. And now if you want to enter millivolt, you have to say, okay, enter 0.005. Then that will be millivolt. However, again, variable cannot be go with any unit. Just a number. That's the way the the value can be stored into the location in the computer. Okay. Now, after that, you go to the man, void man. If you learning the program, void man, that means no return. But we don't care about that right now. Okay? On the thing that one here, you just leave it that way. Set up system, that make the color. Integer you cannot change. However, version date you will be changing. Everything you read it, you can see. I already put a comment here. Change the date. Semester could be changed to the what semester. Section 1 or 2 also be changed depending you 1 or 2. Typing change the last name and change your first name. Okay, that program will be a calculate sample. That means whatever program name. Okay, and that one, okay, do not do anything. You start with the tab number 1. Okay, so if you're looking in Excel, they already given you tab number 1, the title, calculate the current IB. Okay. You see that, calculate the current IB title. And now for the formula, if you want it, and you can copy formula okay, from Excel and paste it out here. But they just comments. Expected value. If you look in here, they say value they want 0.43. So that's why 0.43. And the unit they want it milliamp. So unit will be milliamp. Okay. Then now you do calculation. They want calculate IB. Okay. Okay, then you can type in double IB equal that the formula right here. VBB minus VBE divide RB. Okay. I put that in here, comment in here. Okay. So that's done for that number 1. However, if you're using IB here, then calculation value have to be IB. And the check the calculation is my program, cannot be checked. So that's done for test number 1. And now you can copy that number 1 and paste it out. Then test number 1 to test number 2. Okay. And also that title, that will be in the Excel. You can see, you can look into the Excel. Calculate the current IC. Okay. Calculate the current IC. Okay. And the formula that also from Excel. IC equal beta times IB. Okay. Expect value from the Excel 64.5 unit, they want milliamp. And now you start calculate double IC equal beta times IB. Okay. And also again, if you're using IC here, then calculation value must be IC. So you can keep copy, paste it out, okay, and get another tab. However, on the tab, okay, what they said here, edit your program above this line. That means you can working in here. You cannot go down to this part here. That's my program. Okay. So now you done up to number 2. Don't try to do every test at the same time. If you done for number 1, you can compile that first. Okay. Then to see you get any error or not. Okay. Now I say I compile, go to build. Okay, you can build. And they telling you get error or not. Okay, build 1 success. That means no error. Okay, now you execute your program. Go to debug. Start without debugging. You see that? Fail that one. Fail that two. Okay? So we get a fail. So now you go back into your program to see how come that one it failed.
Sorry to bother you. What's the difference from the self or the one without or the one with the start? Where you put the debug? Because it says without and then with debug, something like that.
Okay? You say on the debugging, right?
Yes.
Now, debugging here, normally you start without debugging. If you you want to run debugging, you have to set the breakpoint. So the program, when they hit into the breakpoint, they will be stopped there. Okay? Only thing is, when you get really good how to do that, either delete or calculation, then I can take you run with debugging. Debugging will be using for troubleshooting. Okay? So
Okay.
now,
Thank you.
now, can you go to the test number 1, why fail?
It might have failed because of the 2 quotation marks over here. It probably needs to be tapped over because there's a
No.
little.
Now
wiggle
that's a
button.
syntax error. We don't have any more syntax error. Now the problem is when you're done to run, the test it fail.
You need to change it to milliamp.
Exactly. Now, if you see this formula, IB equal VBB. VBB is 5 volt minus 0.7. Divide to RB, that means resistor, 10,000. So IB coming out will be ampere, not milliamp. However, the unit here, I want it to milliamp. So that's why you better adding one line to 10 into milliamp. IB equal IB times 1,000. That's what command here. Convert to milliamp. Okay? And after you're done, you have to compile again. View. Compile. When we can in program, must be compiled. So they be converting to the binary. Okay, so we'll be successfully. Now, run again. Debug with the okay. You can see that. When you get 5 or 10 or more tests, all have to be part. Okay? Only thing what you need to do, you can upload your CPP file on that one. If you don't get along with CPP file, you can copy again, Control A, okay? And see that, Control A and Control C, you open the notepad, okay? Control C, you open your notepad. And now you can Control V. You pass them out. And this is you can upload this file so we can check it. So Mr. Sam will be run your file here. Okay. If it passed, he let you know. If it failed, also let you know you have to redo it. So that is the whole thing for using the Visual C++ to do the E calculation. In the past, they're using the basic that you all no more basic. We're up to date, so that's why we're using C++ program. So any question, anything?
Yes, I got a question. I already did it, but it won't let me open it.
Can you share for Sam?
Sorry?
Can you share that so Sam can help you?
Yeah, sure, I'll share it.
Okay. Don't say, I don't care. Okay, so you can share to see what's going on.
Can you go back? Okay, go ahead and cancel this here. Cancel it. Okay, when you go to File and then Open, you want Open Project with Solution. The one on top said Project Solution. Okay. Here, okay, so you have a couple of them. You have one called Calculation Program 01. The other one is you got Sample Calculation here. You see on your file? You see it? No. Yeah, so you have that. So you have, yes, go ahead and click on that to open it up. Okay, so it doesn't show. Go ahead and click on say View. You want to do a Solution Explorer on, choose a Solution Explorer. Okay, right there. And you come over here on the right side, you want to go to the bottom there, double click on that. No, on your programs, the Calculation Program 01 on the bottom, the very bottom, double click on it. Okay, that's your software. Okay,
Thank you, Sam.
you're welcome.
Okay, any more question? These are very important, not for Tech 1. and also for
Hey, I got a question.
Go ahead, Nicholas.
Okay, so I'm getting a, hang on, sorry.
I just mute
So
it.
mine,
You turn on your microphone.
yeah.
Okay, go ahead, Nicholas. Go ahead, unmute yourself, and so you can talk to us.
Can you hear me now?
Yes, I can hear you now.
All right, thank you.
Okay.
So my program's failing on the fourth
Okay,
test, and
can you
I
click
can't
on
figure out
share
why the voltage test.
Okay, can you click on
Yeah.
share screen, and so and then share the screen with us, and so we can help you.
Shoot. Sorry, I just installed it on my computer, this Zoom, and so I'm not quite sure how to work it.
That's okay. And this is the learning. Okay, so if you look at the bottom of your on the Zoom meeting, and it should be in writing in green, it says share screen. You click on that button.
Oh, okay, sorry.
Okay, and then after that, you look at the screen that
Oh,
pops up.
I
You
got it.
should have multiple screen and choose the screen that you want to share with us. And then
Gotcha.
click on that screen and click on share.
Okay. There we go.
Okay. Okay,
Can you see it?
okay, yeah, we can see it now. Okay, go ahead and run
So,
it. And okay.
okay.
And say film test 4, correct?
Yeah, there it is. Okay, so it fails on test 4.
Okay.
And then let me show you my code. I can't figure out what's wrong in it. Can you see
Okay.
it right now?
Yeah, we can see your code.
Go to debug and
Cool.
try to run to see what happened.
Go
So is this
debug.
some
Debug. Start without debugging.
Start with, I did. Here, I'll do it again. There. Fail test.
Click debug.
yeah, make sure you close the one that you have already run, the debug. The other one, you have to close it first before you can run a new debug.
Okay.
Can you see my little screen on
Yeah.
my blackboard? Okay, so therefore, this is your formula, which is on line
Right.
67.
Yep, that's what I have in there. VRC equals IC times RC.
Okay, so we look at so IC times RC. Okay, now we look at your previous step. First thing we want to find what IC would be. Okay, go ahead and scroll up a little bit on your program. Okay, I want to find that IC. Okay, look like IC is on test 3, right? No, test 2.
Yes.
So IC, so I'm gonna write down IC is equal to 64.5 milliamp.
Yeah.
Okay, and your RC is defined on the way on the top when you declare it.
Yep.
And you declare as 100.
100.
Okay, so now you look at VRC. Would you do now you want the answer is to be in volt, right?
Yes.
So they want in volt. So therefore we have to convert this IC into amp first.
Oh,
And this one is in ohm. So we have to convert this one to before we use this equation. Okay. So therefore, before you do this equation, we need IC. Yeah, you said you're gonna put IC is equal to IC divided by 1000. So that would bring it to amp. And so that way, when they take the amp multiply against ohm, we get volt.
okay.
Okay.
So it would be IC
Mhm.
equals IC divided by 1000.
Mhm. And that line is to convert from milliamp to amp.
Okay. So does that look right? If I
Yeah,
if
don't
I
forget your
debug it?
don't forget your semicolon to
Now the
close that
thing is you need
statement.
Okay.
semicolon.
Okay.
Okay, now rebuild it.
Okay.
So that's how we analyze. We write down the formula and look at whatever the
Yeah.
value in previous step, because then
Yeah.
we put in the calculation and then we can define what do we need to convert first.
Okay,
Before we-
now go
Cool.
debug.
Yeah, I did. I don't know if you can see the window open. Yeah.
No,
it passed
yeah,
now.
you can only share one window at a time.
I
Right
get
now
you.
you're showing us
Here.
your software.
Let me see if I can figure that out real quick.
Okay, so you stop sharing this one first. Click on stop sharing. It's on top. It's in red. Click stop share. Yeah, it's on to your top of your screen and it should be in red. It says stop
Oh, I see, I
share.
see.
Yeah,
Yeah.
stop sharing. Okay,
Okay.
now you can share the other screen. Click share
Okay.
screen and
Yep. All right, thank you. I've been doing Zoom on my phone. I haven't used it on my computer till just now. So
yeah, this is something that we all have to learn, for everyone.
you.
So that's the best way is to share the screen so we can help you quickly.
Yep.
Okay,
Okay, so
thank
you
you.
can see it now.
Yes, you're doing
Cool.
good, Nicholas. Okay,
All right, thank you. I appreciate it.
all right, excellent.
Okay, any more questions? Make sure if you still can feel anything, bring it up. We're not return coming back anymore.
Yeah, so if you missed it, you have to go watch the video.
Okay? If it's not, then we will go into the bipolar transistor.
Okay.
Let me get to my iPad. Okay, last time we already done. Now we're talking about DC bias. That means the transistor of, PNP, NPN, they must get the DC to make the transistor working. Okay, and this one, they using two power supply, VCC. Volt. Okay, right here. And also VBB, 5 volt. And on the formula to doing calculation, we already given to you. IB equal, IC equal, VRC equal, okay? And this is just an example you have to do. And just a different one. Now, this is another way to bias the transistor. They're gonna add meter feedback bias. They will be connected this way. However, they say better than the Bay bias. Q point still moving and not popular, not be using. Okay, but however, my question is, how come they say better than Bay bias? This is a Bay bias here, okay? And this will be emitter feedback bias. How come they say better than Bay bias? Who can tell me? compare for emitter feedback and the Bay bias. How come they say Bay emitter feedback better than Bay bias?
Because it has two resistors.
Come on. Who knows? Okay, you guys don't know. The only thing is, on the emitter feedback, they're using only one power supply. And the other one, they're using two power supply. Okay? That's the problem. And they're not popular. The thing is, this one causing Q point can be moving. That's what they don't want. The next one, this also Bay bias, the least predictable. Q point move. Q point move with temperature, not practical. I just showed so for you guys when you see it, you know. If you want it, that value, that's easy. Just go to the simulation. They're giving you any value you want. Okay? And this what they call collector feedback. Better than emitter feedback. Q point still be moving. Will be limited application. So that's why when you're working, you can see if they get a transistor, you do not see this kind of configuration. Two power supply emitter, bias. This one they're using a positive here and a negative here. And they say it's very stable. That's okay. However, they require two power supply. You understand on the circuitry, cut must will be power supply, not transistor, not resistor. Okay? Power supply cost not money. So that's why they don't want. Okay?
Mr. Pham,
Yeah.
can you go back to the one that was called base bias with the two power supplies? You're right there. I guess what I'm trying to find out is the names. They call this a base bias. What's the difference between the base bias and the self bias and the fixed bias? I mean, as far as I'm trying to get a better understanding between the fixed, the self, and what they call base.
What they call a Bay bias?
Is there another name for this? Is there another name for fixed bias? I mean, base bias?
This one is emitter bias. This one will be Bay bias.
Okay, so
You can see this one together, RE. The other one don't have it.
okay, then what's the difference between self and fixed bias then?
What do you mean fixed bias?
I think last semester sometimes you use the term fixed bias and self bias.
Oh, you're talking about JFET.
Okay, that's where I'm getting mixed up. That's
Right
why.
now, we're talking about
Yeah,
bipolar.
bipolar, I understand.
Okay? That's that example. You can see they're using formula. Now, this is the one you need. Normally, when they using the transistor bipolar, they're using voltage divider bias. You can see that they need only one power supply. However, they want the voltage at the base they just add two resistor. And the voltage here will be equal VCC times R2 divide R1 plus R2. So they can get the voltage here. Instead, you need another power supply, got more money. Resistor were very cheap, 5 cents, or 10 cents, or 15, or 25, depend on the tolerance, okay? So after you get VBB, you want to get a VE right here. You understand from VBB go to that admitter to get plus minus 0.7 volt. This is a diode here. So that's why you want to calculate the VA. Then you take VBB minus 0.7. And after you get VA, you can calculate the current IE right here. IE equal VE divide RE. Okay? And after you get the IE, then you're able to calculate the IB. The formula will be IE divided by beta plus 1.
Mr. Pham,
Yeah.
I think that formula is wrong. IE equal VE divided by IE should be RE.
Oh, thank you. That have to be RE. Thank you. What else? If you want to calculate IC, beta times IB. If you want to calculate the VRC, that means the voltage drop across RC, IC times RC. Okay? And if you want to calculate the VC right here, that will be VCC minus IC times RC. If you want to calculate the VCE, then that will be equal to VC minus VE. This is very, very important configuration we'll be using all the time. So, any question on that? Okay, if it's not, this is voltage divider bias. Okay, let's see. If the base current IB is much smaller than current I2, right here, through the R2, then a voltage divider consisting of R1 and R2. Okay, so VBB equal VA. That means the voltage here times VCC times R2 divide R1 plus R2. That's normal. However, last semester or before last semester, one student here, engineering, he complained. Is what he said, from the BB here, go to the round. Also, you get a resistor. Okay, that's what they call a R in base. That means resistance from the VBB to the round. So in order to do it, we have to calculate I in base equal VBB divide IB, okay? And VBB, the base, VBE plus IE times RE, okay? So basically you have to calculate the voltage from VB to the round. That means from here to the round, you get 2 voltage. You can get a voltage VBE. That means right here. And also VE in here. You can divide it. Okay? You see that? VBB. VBE plus VE times RE. That means VE. Okay? And also VBB, the base, equal beta times IB times RE. So that's why they come up with the formula. R in base equal beta times RE. Only thing I want to tell you, they want to make sure you get another resistor. Okay, from the base here. Go to the round. That's what they call R in base. And now you have to combine that one and that one to get one resistor before you can apply VCC times R2. Now it's not R2. R2 will be combined with this guy. Okay? That's for more accurate. However, R in base normally much greater than R2. So 2 parallel. R in base higher than R2. So that's why they ignore R in base. So that's just so for anyone want to go to be engineering.
Hey,
Then
Mr.
you
Pham,
have to deal with that. However, we never. Normally, you calculate the VBB will be VCC times R2 divide R1 plus R2.
hey, Mr. Pham, that's what I was, so essentially you're saying before you do the VCC times R2 divided by R1 plus R2, you have to put the R in base in parallel with R2, and then whatever value you get, then you use that that formula to get
Exactly.
VB. Is that what you're saying?
Exactly.
Okay, bingo. Thank you.
However, what I'm saying here, R in base much higher than R2. Okay?
So therefore we don't have to worry about that.
Exactly.
And you won't put that on the test, right?
No, we're not using that. But I try to explain. If when some student reading here,
Mhm.
hopefully he's able to follow it.
Okay.
Okay, now, before we keep going, what I want you to finish that for me quickly, few minutes. Go ahead and do it. Let me know the answer. Okay, what B equal? What I get? 3.59. If you not get that, let me know.
So it was 10 volts times 10K divided by approximately 15.6K. I get 6.41.
Say that again, Joe.
I get 6.41.
No, say how did you calculate it?
Okay, yeah, you're right, I did it wrong. It's supposed to be 10 times 5.6K divided by 15.6.
Right. And VE 2.89. Okay. IA 5.16.
3.589, yeah.
Milliamp.
Minus 288.89.
IB okay, 5.16 divide 101, I think so. Is it 005?
Yes.
Okay, thank you.
That's right.
I see. Time 100. Five and one. VRC. IC time RC.
1,000 times
5.1.
5.1.
5.1 volt. VC. VCC. Minus IC. RC.
Yeah, that would be minus 5.1.
Which one?
So it's 10 volts minus the VRC is the same thing as ICRC.
Exactly.
So that's 4.9? Okay, 4.89, 4.9. Minus 2.01.
Okay, you take 2 4.89 minus
2.89.
2.89.
Yeah, I got 2.01, but it's the same thing. It's basically 2 volts.
So from now on, when you see that divider circuitry here, you have to do in calculation right away, quickly. Okay, so any question regarding into that?
Yeah, sorry, is there a way you can do the same thing you did with the F, G, and H, do the same thing to the A, B, and C, and D?
Can you say again? Get same thing what?
Like how to like C, B, C, C minus I, C times R, C?
Same thing. IC times RC, that means VRC. You get the voltage here. And now you see how much they drop from this one. Then you get the VC. Same thing. Okay? Okay, now I want to get it done. I hope that will be.
So 10 times.
VBB will be the same thing. Okay? I can give it a formula. I don't need to do calculation. Okay? That take more time.
Yeah, that's what I was just asking, the formula. Sorry.
VEE time R1 divide okay.
It's 0.875.
Yeah, I don't care now.
Mhm.
We need to move it.
Yeah, okay.
Okay, VE.
It's going to be VB minus VBE, which is 0.7.
Okay, now VE mean what? If I given you guys the DMF,
Oh, I see. That's right. That's I'm looking at the wrong thing. That's the
Okay.
collector. This is a PNP.
right? I given you a meter. I want to measure VE. You connect high side to E, low side to ground.
Yeah.
So from VBB here, okay, to the ground, you already get the voltage. And the difference between E and B, 0.7. So VE to the ground have to be added.
Mhm.
VBB. Added,
Plus 0.7.
okay?
Yeah.
And now,
Oh, yeah. Sorry about that, Mr. Pham. That's a PNP.
right. Okay, current IE. That means they got to get the current right here.
Right.
So they will be equal VEE minus VE divide RE. Minus VE. And you know that IB equal beta time. Sorry. Okay, IE divide 1 load beta IC beta time IB. Okay, and VC equal
VEE,
now VC. VC that means here to down.
right.
VC equal IC time RC. And the last one, VE
Oh, yeah.
minus VC. That's all the formula you need. The first for NPN, second PNP. Try to get along. Okay. The thing in interview, they can asking you. They don't asking you to do your calculation, but they asking you how. Okay, you done? Go next one. Okay, you can see on that one. This voltage now will be negative. The one we just working on, they're using positive. So on that one, everything, I already given you the formula. VBB, same thing. VCC times R2 divide R1 plus R2.
Mr. Pham,
Yeah,
my only question is, if you just elaborate on IE, because in your formula, you got 0 minus VE.
I don't know. I go down, okay?
And you got it written on here, IE equals 0 minus VE divided by RE. And that's because it's coming from ground, right?
Right.
Okay,
However, we'll see. You can see the current flow.
right,
That will be IE. Okay?
right,
That will be VE. That will be VC. Okay?
right,
So now, to calculate the VBB, we already know.
right,
Okay. VE, you want to calculate the VE. Okay. VE equal VBB plus 0.7. This is the positive here. Minus here. 0.7. From here to here, that's what you get VBB. And
Right.
from 8 meter, go to here, you get 0.7. From here to the round, okay? So that's why they get VBB plus 0.7. Now, how come I said IE equal 0 minus VE divide RE?
Because your grounds is 0, and then VE is higher than 0.
VE will be higher than 0.
Right.
Okay? So basically, positive here, negative here. Okay, so
Mr. Pham, just now when you said something, you didn't use your cursor, so we didn't see what you were doing.
okay, we try to find out. Okay, basically you already get the VE,
Right,
and this is a round.
right.
So you want to calculate the IE, you take VE divide to RE. You see that?
Mhm.
Okay. However, if you say the current goes this way, then you have to take a 0 minus VE, right?
Right.
Divide to RE. So 0 minus this one, you can get a negative. Okay?
Okay.
You can get a negative number. So basically, I don't think you need a 0 minus. The thing is, the current here, okay, will be VE divided to RE. However, the current flow this way. Okay? So that's why we put a 0 here. And you know you don't have any negative current. Anyway, they come up with VE divide RE. And if you get IE, you can calculate IB. You can calculate IC. Let's see, VRC right here will be IC times RC. That's correct. VC, that means this from here to the route will be VCC. VCC blood IC times RC. So basically, you can get the current. Suppose you go this way. IC, and this will be IB. So VCC will be higher than minus VCC. After you get the IC, okay, you can time RC. So that's why you can get VRC. After you get the VRC, you take the difference between VCC and VC. That's what you can get the VC. VC, that means from here to the route. So this is the formula. Only thing you make sure VCC will be a negative. If you want it, you can run the simulation. Okay. Now, the last one, I think, that's what they call a Darlington connection. You get two Q, Q1, Q2. Admitter connect to the base. The reason they want to do it, that's telling you they want more current gain. I given you the example. For this one, beta equal 100. On this one, beta equal 100. So the gain will be 100 times 100. You see that? Only telling you when they want to get more current, they using Darlington connection. However, whenever you're working on Darlington connection, have to be very, very careful. When you try to measure, and for some reason, your route touch into here, okay, they will be cooked right away. I think that's a very high current. They just show you, you can do it easy. Get two transistor, make a connection. Then you get a Darlington. However, you can buy the packet. That means they build inside the packet here, okay? Darlington transistor are manufactured with a transistor in one case, okay? This is separate build. This is they already built in one side of the IC.
Mr. Pham, what did you just say? You said something can't be connected because it'll cook it. Could you go over that part one more time?
Okay, that's what you're asking about when you try to measure. When you measure, you're using the meter, DMM high, DMM low. For some reason, DMM low, it touched to here. They will be cooked right away. The circuitry. The thing is high current. Or mostly the people using oscilloscope and the round of the oscilloscope easy to touch into here. So that's why circuitry will be burning right away.
So let me see if I understand what you're saying. You're saying don't take the negative lead of the scope or the DMM and touch the emitter.
Exactly.
So you can use the red lead, but not the black lead.
Right. However, meter, if you're using both, both sides, okay, do not connect the black into the route. Sometimes you hit them to the problem. And also, most of lately, the people hit into the problem when they're using the scope. Oscilloscope, you get a negative route. Okay, you connect it by the wire into the route. So when you try to measure, that can be moving around. If they touch into the admitter of this transistor, they cook right away. So that's why very, very careful when you're working with the Darlington connection.
Mr. Friend,
Yeah,
with the oscilloscope, is the sensitivity with the 50 ohm resistor? Or is it mainly just ground?
the draw.
Just ground only. All right, thank you.
Yeah. Okay, so we're done with that guy. Okay, and now we go. Let's see. That one. Amplifier. Make sure the guy already downloaded. Okay, now we start with the amplifier. You get 3 configurations. Common emitter, common collector, common base. Also, you understand in JFET, you can get also the same thing. 3 configuration for the JFET. That common source, common drain, and common gate. If you understand that thing, easy to understand another one. Okay. Now, first thing they're talking about capacitor, coupling capacitor. Okay. Good coupling. I say less than 0.5 R. That only thing for designer. When I design the circuitry, I want perfect coupling. Okay. Then I have to pick, I say will be less than 0.5 R. R will be 100 ohm. Okay. Then I say calculation have to be less than 10 ohm. Then perfect. But we not design, so we don't care. However, we care on this thing. Capacitor for AC, they sorted. So that's why in AC circuitry, you never see this capacitor. They sorted throughout. No, sorry, sorted just like wire. However, for the DC circuitry, capacitor, when they full charge, they will be open. That only telling you one thing. Capacitor in AC, they allow current to flow. However, in DC, no more current. The thing is open. Okay? So that's why they say here, AC analysis, capacitor is short. DC analysis, capacitor is open. That's a very important. You need to know. Now, for any student really want to learn more about AC, then you have to follow this instruction. First thing, amplifier analysis. First thing you have to do, perform a complete DC analysis. That's what we already done. Have to calculate the VBB, VE, VC, VIE, IC, okay, IB. Then source owned coupling and bypass capacitor. That means capacitor, when they go to the AC, you didn't see anymore. They sorted, just the wire. And like one, visual on DC supply, voltage at AC routed. So that's why any DC voltage in a DC bias for AC, they just sorted to route. Then you replace transistor by different module, pi or T module. Draw the AC equivalent circuitry. Now, this shows you one thing. This is a transistor for DC, and this is a transistor for AC. Okay, and you understand this still be B collector emitter. Okay, so this one a module for the transistor in AC. That means from the collector go into the base, you get the current beta IC, beta IB. This is the current IB. And this is the current IE. However, now you can see from the base to the emitter, they don't have any more diode here. You see that? They substitute by resistance. And that resistance will be R prime E. That's what they call internal resistance from the base to the emitter, and will be calculated by this formula for bipolar. We cannot get. If you want to get the value of R prime E using this formula. Okay, so for the AC, we deal with this transistor. Okay, and also they given you formula here. J in B. Okay, now what that mean J in base? What is it?
The impedance?
Impedance.
Yeah.
Remember, Z impedance. Okay. J in base. That means input impedance. What that mean? That means when you're looking to the base, whatever resistance you get, that's what they call input impedance. Okay. The thing is, when we deal with the amplifier, you have to deal with the input impedance and also output impedance. Okay, we'll be see more. This one you already know. You get the input here, you get the output here, the gain 200, and gain will be by definition ZV out divided to VE. That's the gain. Okay, now on this circuitry here, they call it common emitter. How come? First thing, in order to recognize common emitter, common collector, or common base, you're looking into the circuitry to see how the input apply and how the output will be coming out. So for the base common emitter, input here apply to the base. This is the base. Output from the collector. This is the output here. Okay. What they said, input signal to the base, output from collector. That basically definition. Okay. And also they say input, output 180 degree of phase. That means the input here and the output here, they will be opposite. Input positive, output negative. Okay? Input negative, output positive. That's what our phase. Okay. C1, the name. C1 they call a DC blocking or AC coupling. That only thing, make sure they not allow any DC from the input here go to the base. However, they allow sideways AC go to the base. That's what AC coupling. DC, that AC2, DC blocking. You understand if you calculate the DC bias, you get the voltage DC here. And this is the output here. RL means your speaker. Okay? Like your voice coming in. Go to the speaker. When you go to the speaker, you don't want any DC from here. Go to the speaker. So that's why they need the C2. They block that DC. They allow only AC to go. Okay? And the last one, C3. C3 is called a bypass capacitor. The question is, C3 bypass what? What bypass?
RE.
What C3 bypass?
RE.
RE. Exactly. Now, at this point here, okay, you can get AC will be 0. How come? The thing is current IC, they go to C3, they sort to the route. Okay? So that's what they call a bypass. This current cannot go to RE. So that's why they bypass RE. The reason how they want bypass, whoever been here before, you can tell me. C3 bypass are big E. Why do we need that bypass?
A better amplification, the gain.
Will be increase the gain. That means they want the gain bigger. That's why they bypass. If not, without bypass, the current will be lower. That is the purpose. I try to make it clear when you see into the picture. And you're able to answer any question regarding into that configuration. Normally, they can ask you what the name of C1 and second thing, the purpose of C1 or C2 or C3. C1, C2 is DC blocking, AC coupling. C3 will be bypass. Okay, your technician, you need that one. That one is a very good one. They give it to you. You get sideways here. Okay? And also, they give it to you. This sideways will be go to here. However, at this point, you get 2 voltage. One will be bias, VBB 1.8 volt. And this will be your signal sideways. Okay, when you're working on your lab, you measure at this point. You can see you get two signals. Okay. However, if you want to measure the peak-to-peak voltage here, what oscilloscope will be set to? You understand this on oscilloscope, you can set DC coupling and AC coupling. So if you want to measure peak-to-peak voltage here at this point, which one will be set it up?
AC coupling,
What coupling? I said you get two. You set DC coupling or AC coupling?
AC.
AC coupling. The reason is, that is, you understand, input is microvolt. This is a 1.8 volt. So it's too big, so you cannot see this one. The thing is too small. When you set your scope to DC coupling, they will be displayed both signals, DC and AC. And the DC is too big, AC is too small. You cannot see peak-to-peak here. So that's why you must set AC coupling. So they remove that 1.8 volt. Now you can measure. Same thing happened at the collector here. Collector DC, you calculate 6.04. However, also you can get a sine wave, a little bigger than input here, opposite. However, compared to 6.04 volt, it's still hard to see, very hard to see this signal. You must be set your scope to AC coupling. When you go into out here, you can see you don't have a 6.04 volt. Now you get 0. The thing is see to block 6.04. Okay, then you can get the output. And if you measure at this point here, you can get DC. However, no more AC. Be sorted to the ground. That's a very, very clear for a completely signal will be shown on the common meter amplifier. Okay, you get any question, anything? Okay, if it's not, this is basically they just talking about AC module. Okay, let's see. You can get in here. This is the collector right here. This is the base. This is meter. Now, when they say common meter, that will be telling you in the AC, meter will be round. That's what they common meter. When you learn common collector, in the AC, collector will be round. Common base in the AC, they will be rounded. Okay? And now you can see no more power supply DC here. So if you see R1 one side connect to the base, the other side before they connect to VCC. However, VCC will be rounded. R2 also connect to the base and rounded here. Okay, and admitter will be round, common admitter. At the admitter, you get two resistors. One RC, one will be the load. Okay, and this will be round here. They will be round. So that's why you can see at the collector RC, one side collector, the other side round. RL, one side collector, the other side round. Okay. So now, if you want to calculate the input output impedance, you're looking at the output into the amplifier. Whatever you get, that's what they call it. G out. G out means output impedance. And if you're looking into here, easy, you can see RC, RL in parallel. In this textbook, they're using RC. They the same thing with G out. The thing they're using the lowercase letter. That means resistance for the AC, not DC. Equivalent to output impedance. Okay, and now input impedance, your source right here. Okay, you're looking into the amplifier. Whatever resistance you see, that's what they call a G input impedance. If you're looking into here, you can see what you see. From the input looking into the amplifier. What you can see.
R1, R2, and RE prime.
Okay, the first thing I can see is easy. R1 parallel R2, right? Correct? This is R1 here, R2 here, both connect to the round here. R1, R2 parallel. You see? What else?
R prime E.
R prime E, that means internal. You still get one more resistor. I'm telling you. That resistor from the base. Okay? To the round. This resistor, they go up. In base. Okay, so basically G in R1 parallel R2 parallel R in base. That means 3 resistors in parallel. Okay. So the next meeting, we will go into calculation. Okay. But in general, when you get into the AC module, then they have to deal with the input impedance, output impedance. Okay. Then also they will be deal with the gain, AC gain. Okay. That means your voice coming in, how big when they coming out. Okay. Any question? Basically, to really understanding take for a while. Not easy. Okay. Okay, any question to me? Okay, if it's not, we'll see you next week.
Student needs some help with the homework number assignment 11.
Okay, so I can stop share.
Thank you.
Just a minute. Oh man, let's see. Stop it.
Okay, thank you. Okay, so we're going to go, I'm going to show you the assignment 11. So let me go ahead and share the screen. Okay, can you see my screen, the assignment 11 with the MSIM 7, Louis, or?
Yes.
Okay, okay,
Yeah, I see it.
okay, so so are you okay with this? Do you know how to get all the parts that put it on here, or?
No, I couldn't get that. I made mine, but it does not look like that.
Okay, so the transformer, this one would be the transformer that is on the list, which is this one right here. Okay. And then after that, you click on that and you change the primary, secondary, you change to how many it turns. You type in 5 and click OK. Can you see that? Or
Yes, I can see that.
okay.
You want me to show you mine so you can see what I'm doing?
No, I'm gonna need to go through this one real quick. Okay, so
Okay, no worries.
okay, so when you'll see, you put here 5, click OK, and that would change to 5. So that's where I was able to put this one here. And the other one that we need is this this bridge. So you want to do is go to your selection. It's in your diode. It should be on the very side here. You want so the third one, which is the diode, you can see it on there. When I put my cursor on it, it's a diode. I click on that, and then I bring up this here. Okay, they give you the selection menu. And then you want to do, this one is going to be your diode. Okay, so we're going to be so you're going to be, now it's going to be in this one right here. Look like a 1, 2, 3, 4. The fifth one down, it's that one right there. That would represent the bridge. Okay, this bridge here.
Got it. Can you show me that? I didn't see how you got that to like the component.
Okay, so you want to do is come into the left side here. You go down one, so you got the source, and you got your basic component, and you got your diode. So the third one down, click on that, and it will bring up this menu selection. Okay.
Okay, I got it.
Okay, and then when you come down here, you want to do is click on the ones that FWB. That would represent for your bridge rectifier.
I see that. Thank you.
And then you want to click the one that's at 1B4, B42. So that is the one that we have, which is the first one on the list here. Okay, and click OK, and then you should be able to place it on your work table. Okay, so the next thing you need help with was okay. So you're okay with all the other parts, or you?
Yes, I'm okay with everything else. I just couldn't get that diode thing to get to work. I had like 4 of them put together to make it into one, but it was all weird.
Okay, So the next thing you want to do is get your oscilloscope, which is the one way in the bottom here. Okay, so, and that's what is this one here, XSC1. Okay, and then you click on it, and then it will bring out. So if you double click on it, it will bring this one here. Now I already turned the power on. Now when you see when it first comes on, it will be black screen. You turn the power on. Now it's on. Okay, so you have is so this one is representation. So right here, this one here, this represent your channel 1, which is this one right here. Okay, and this one here would represent your channel 2, which is this one here. Okay, so now I'm going to put sort of drag that one to the slide a little bit so we can see both of them. Okay, so the first one they said to measure TP1. Okay, so TP1 we have is the TP1 is right here. So now they're already assuming that you know to connect the other one to the ground. So but I'm not going. So in this case, they only give you one wire connection. So you connect it there. Turn on your simulation. Okay, now my simulation is way above, so therefore I sort of adjust my volt per division here to make it a little bit smaller so I can see. And let me see, adjust it in my frequency. Okay, so now auto scale, you can click auto scale. That should be able to bring it quicker. Okay, so next thing, so channel 1, I want to see DC coupling. So let me see. Okay, so DC coupling. Okay, let me reconnect this one here. Okay, turn it off. So okay, so reset it. So this one is connected here to pin 1. Okay, so now we turn on this, turn it on, turn on your simulation. So now you got this, look like it's way out. Now I had to adjust the frequency here to down a little bit. So too much. Okay, and then we're gonna be, okay, there it is. There's my signal. Okay, so you're gonna play around with it. You adjust this one for the timing and this one adjust for your voltage. So I can stretch it out, compress it. Did I change? Did I put? Okay, so all right. So turn on, turn off. Okay, so I need to stretch it a little bit. Okay, so you sort of look at something like that. Okay, let me see. Let me change this setting a little bit so I can see the back. I'm going to use the black background. So okay, so can you see that much clearer than the other one?
Yes.
Okay, so with this black background, and then you want to do is you can stop it, and then you can so either you do a single run, so that way it do a one complete, and then it stop for you, so you can go through and measure. Now you can use the cursor here to measure, or you can call in this one you have a quick meter. Okay, so click on that, and you want to look at point TP. So therefore you want to look at the peak to peak. Okay, so click a peak to peak. It's registered 339.41 volt peak to peak. But the answer that according to the schematic, they want only peak. So you take that number divided by 2, and that's what give you only the peak value. Okay.
Okay. Appreciate it. Thank you very much.
All right. So that's how you measure. Just kind of do that, and then just do that. Just kind of adjust your screen. Either use the volt per division to shrink down your circuit, your signal, or stretch and compress your signal. Okay, and you use the single to let it run one time, and so you can stop it and you can collect your data, and you can click on clear meter to clear it up. And then if you want to change the source, like Mr. Pham was talking about earlier, either you use the DC coupling or AC coupling. You want to do is click on the source, which is channel 1, and then that bring up the sub menu. So you got the coupling right here. So you click on that. Now you can choose ground coupling, DC coupling, or AC coupling. Okay, depending on where you want to look at. When you do the ripple, it's in the millivolt, so you're most likely going to have to use the AC coupling. Okay.
Okay.
Okay, so the ripple, you have to use the AC coupling, but on the DC, but all the other one, you can use DC because it's big voltage. It's in the VP. And when you look at the millivolt, it's in the small signal. So you have to use the AC coupling to get that. All right. So any other question or? do
Yeah,
you
real
want me to-
quickly, how do you go from black background to a white background?
Okay, so you click on the display here, display button. And then you have this one say clear grid, black, so back BK color that represent your background. So you click on that and then you want to do adjust it with this adjusted button right here. So you can adjust it to very, very bright, or you can go use a darker background.
Okay, got it, got it.
Okay. All right, any other question or? Is that clear? Okay. Any other question that I can help you with before we close out for today?
No, that'd be good. Thank you, Sam.
Okay, you're welcome. Also, Mr. Pham, look like the student was having the on Tech 2 student, they're having they weren't able to work on the assignment e-review number 4. There's some errors in e-review number 4. So on e-review number 4, I worked it on earlier, and the one that there's no, you did not set this one right here. So the answer here is set in 0. So therefore you can't get this one to pass.
Okay, so you get the first one. The second one, you converting from hex to the binary.
Yes, this one, yeah, we're able to do this, but when they do the check, you don't have anything here
No.
that you.
I don't
didn't-
get check. Only thing is when you get that right, then they okay.
Okay, so I did work on that, and then it didn't come up, didn't come out. So let me see, Tech 2, Excel, the review number 4. Oh, this one, because I went through and set up this the check here. So now I set up the check here. So now we have this value here. So they would check and they will give the correct answer or not. Okay, so but before, the one that before, it doesn't have it. This one over here that they didn't have it, so I had to go back and redo and set these up. Okay.
Okay.
And okay, so that's pretty much it. Okay, so that's pretty much it. That's the question that student was working on, the D-Lab, the e-review number 4.
So is
for
there gonna
Tech
be a
2.
new one on the web?
Yeah, Mr. Pham gonna work on it and hopefully he'll get it re-upload it.
I will check on that.
Okay, thank you very much. Okay, back to you.
Okay, so no more questions will be good night.
Okay,
night.
good night, Mr. Pham.
Good night.